Good evening everyone. Welcome to my class. Yes, we will start the class. Yes, good evening, good evening. 10 minutes late because in my home power is not there. Without Wi-Fi we can't do the live stream in mobile. We can't. Only with Wi-Fi with cable connection, then connection it will be good. Otherwise you are not able to get the proper signal. Okay. Now the power came. That's why I created the link. Within 2 minutes I am starting the lesson. Normally the link I will create early, then I will start the class 10 or 15 minutes later. Because of the power I am starting 10 minutes late. Okay, only 1 hour I will take. After 1 hour as usual you are having your general classes. Okay. Today I will explain refraction. Yesterday class we studied in detail about the reflection. Everyone understood? No, you don't have any, I think you don't have any doubt in reflection. Yes, no one have the doubt in reflection. Okay, then today we will discuss refraction. Refraction, only two PDF is there. If possible I will see today. Screen is not clear, no, that much clear. Why it is not coming clear, I don't know. I connected the power also there. Then can you see the screen clear? But here it is looking like blur. I don't know what happened. I will. This one is not clear. Screen is clear. Only this slide it is looking like that. Remaining it will be maybe this refraction. Only this word it will be looking like blur. Remaining it will be correct. Yes, no? Okay. What is mean by refraction? When I am explaining reflection only, I give little introduction about the refraction. Refraction is when it will, in which case you can observe the refraction. Refraction is the bending of light when it will enters from obliquely from one transparent medium to another medium. From one medium to another medium, when light bends, then you can see the refraction. Then last class I explained when you are moving from rarer to denser medium, then you can observe the bending of light when you are having the different medium, because the refractive index of per medium it will be different. When you are having different refractive index, then the light it will bend. You know refractive index also, it is the ratio of refractive index. What is the notation? N, maybe n, or okay, it will be speed of light with speed of any object, like speed of light in air or vacuum, like that we will compare the refractive index. Then listen here, next one, speed of light is maximum in the vacuum, that is 3 into 10 to the power of 8 meter per second. Here always we will consider speed of light in vacuum here in the denominator. Then causes of refraction, change in speed. What is the cause of refraction? Because you will observe the change in speed. When you will observe the change in speed, then you will find change in refraction. Then some example of refraction, the bottom of swimming pool appears higher. Yes, no? If you observe the swimming pool, the bottom it will be appear raised up, little raised up, but actually it will be deeper. Due to the presence of refraction, then you will feel the bottom is raised up. Next one, a pencil is partially immersed in water, appear to be bent at the interference of water in air. Here you can observe, this is the best example. Take one beaker, fill the beaker with water and insert one pencil. When the level of the pencil, it will appear in the air as usual. When the pencil, it will be inside the water, it will be appear bent. Why it will appear bent? Due to the presence of refraction. Okay, this is the real position of the pencil. This is the real position of the pencil if you keep inside the water, but actually it will appear in this place. That position we will call it as a apparent position. Real position means exact position of the pencil. What is mean by the apparent position means due to the presence of refraction, the pencil, it will appear bend. Actually the pencil, it is not bend, it will be straight, correct now? But the part of the pencil immersed in water, it will appear bend. That is due to the presence of refraction. Rashmi, good evening. Next one, lemon placed in a glass tumbler appear bigger. Someone maybe in their homes also they will keep lemon immersed in water. Maybe some for I don't know what they will mean, but some they will use in the home. Next one, the letter of book appear to be raised when seen through a glass slab. Magnifying glasses you can use, glass slab you can take with the help of glass slab. You will observe the letters, they will appear big and even they will appear little raised up. Everything it will happen due to the presence of the refraction. This is only the introduction about the refraction. In law of reflection, we learned two laws, like that only we will study the law of refraction. Next, the incident ray, the refracted ray, the normal to the interference of two transparent medium at the point of incident all lie in the same plane. This is same as the first law of reflection. What they are telling, this incident ray, this refracted ray, this normal, everything they will be in the same plane. Can you observe this? All the arrangement, it will be on the board. Means consider board is a one plane. Otherwise consider this PowerPoint, it will be one plane. Then incident ray, refracted ray, this normal, all the three they will be lie on the same plane. That is same as first law of reflection. Next one, the ratio of sine of angle of incident, sine I. Sine I, this is the angle. Okay, sine we will consider. Then this is the angle of refraction, sine R. This ratio is always constant. This is the second law of reflection. This one only we will consider as a Snell's law. The ratio of sine of angle of incident to the sine of angle of refraction is a constant for a light of given color for a given pair of media. Next, we will move to the next one. This one maybe everyone we did in second PUC. I don't know. I did this one in the second PUC glass lab experiment. We will study refraction through a rectangular glass slab. This it is in the form of a rectangle. This one we will consider a rectangular glass slab. Let us study in detail how the refraction it will occur in the rectangular glass slab. Okay, consider this is the glass slab A, B, C, D. We will give the name for this glass slab. Then this is the normal, MN is the normal. Okay, here how you will draw a normal means this is the glass slab means we will draw exactly perpendicular like this. This is the normal. The line passes exactly perpendicular to the glass slab. This angle is 90 degree. Okay, this is the normal. Then consider one here you can observe this is the air, this is one medium. Inside the glass slab you are having the glass medium, correct? No, this is the glass medium. Then outside air is there. Here when the light rays, when it is enter from outside to inside the glass, refractive index it will change. You can observe this is the incident ray. Incident ray, it is coming from the air. Then once it touches this surface, then you can observe there will be a change in refractive index, air and glass. Therefore, it will get can see this one, the refracted ray, and this is the angle of refraction. This is the angle of incident. Then once it touches the surface of the glass slab, then this ray it has to emerge. How it will emerge? It will get emerge. Here also you can observe there will be a difference in refractive index because the refracted ray it is coming from glass to air. Correct? Now here this part you can observe there will be a change in medium. Then at this point the ray it will coming out. That ray we will consider as a emergent ray. Yes, yes, it is there in practical. We did this one in the practical also. Correct? No? Yes. Renuka, good evening. Then here, this is the incident ray. Once it comes in contact with the glass, you can see, you will observe the change in refractive index. It will get refracted once it touches the boundary. Otherwise, once it touches the glass slab corner, it will get emerge out. Actually, you can assume if you don't have any change in refractive index, this is the actual position of the incident ray. Incident ray it has to pass through without bending, but this is not possible because when the light rays when it is entering from air to glass or glass to air, different medium, because of the change in refractive index it will get deviated, it will get refracted. This is the actual position of the incident ray. Here you will observe a lateral shift. Here this is the incident ray it has to pass in this direction because it will not get pass in this direction. Instead of that it will get refracted, it will get emerge in this direction. Then here you can observe the shift from here to here. Correct? Now that shift we will consider as a lateral shift. Here no need to by heart, nothing. You have to remember the diagram. One or two times you draw, easily you can follow. Understood? This one we will call it as a lateral shift. Then this is the angle of incident. This is the angle of refraction. You have to remember. Then this one is this theta. It will be the angle of emergence. This is the emergent ray because this ray after hitting the surface of the glass slab, it will get emerged. That's why it is a emergent ray. Here you can see how nicely the light ray it will hit the surface of the glass, then inside the glass it will get refracted, then all after hitting this surface it will get emerged. Understood? Consider remember the figure. This also they may ask HSTR multiple choice questions. Okay, what is the in the glass slab, how the rays, how the rays they will get pass. Understood everyone? Shall I move to the next one? Yes. Lateral displacement depends upon. Here I told instead of going this incident ray straight, it will get shifted. That shift we will call it as a lateral displacement or lateral shift. Both also same. It will depends upon the refractive index of the glass slab. Refractive index of the glass slab. Otherwise, next one, thickness of the glass slab. Whether the glass slab is thin or thick, and also refractive index of the glass slab. Both also. This also very important point. They may ask MCQ questions. Lateral displacement, it will be depends upon the. They will give different option maybe. Then you have to choose the correct one. Refractive index of glass slab, thickness of the glass slab. Understood everyone? This is very important. Total interval reflection, very important concept. Listen. Understood? No doubt, no? How? What is the pattern of refraction in the glass slab? Understood everyone? We will study in detail what is meant by total internal reflection. Yes. When light goes from a denser to rarer medium, it bends away from the normal. Yes. See, this is the change in, okay, when light enters from, consider this is the denser, this is the radar medium light, this is the incident ray, it is coming like this. Then this ray, it has to go like this straight. Instead of going straight, it will bend away from the normal. This is the normal. It will bend away from the normal when it is moving from denser to rarer. This one everyone we know. If reverse of this one, rarer to denser, then it will move towards the normal. This everything I explained in the last class, but once again I am telling because I know. Then here, when light goes from a denser to rarer medium, it bends away from the normal. The angle at which incident ray causes the refracted ray to go along the surface of the two media, partially it is called as a critical angle. First, I will explain the diagram here. Here, see, this is the glass. Then this one is the air. Then here, consider if you keep any, consider the laser light. Okay. Otherwise, the source here, this is the source. Source of light is the laser light. Consider here, you can observe this is the laser light. From you have to, this is the incident ray. 1, 2, 3, 4. Here is there, no? These are all incident rays. Means you are the sending the rays from glass to the air. This is the incident ray. 1, 2, 3, 4 we are given. This is the direction of the incident ray. First case you can observe, once you send the first laser light without bending, it will travel straight. Everything it will depend upon the intensity of the incident ray. Then second one you can observe, it will come second incident ray, if you send at an angle theta, this angle is exactly 180 degree, correct? No, this one, it will go straight means angle it will be 180 degree. Consider next one, if it is theta 1, consider second angle, we don't know that angle, consider theta 1. Then this is the incident ray, after hitting the surface, then it will get refracted. Here no refraction, this one it will get refracted. This is the angle of incidence, this is the angle of refraction. Then here second you can observe, second third incident ray, not second, third incident ray, angle is, we don't know that angle, consider theta c. C means critical angle, that I will explain. Once it hit the surface, it will neither reflect not refract. This is the refracted ray, this one is the reflection. When the light rays incident is in this direction, if you come to the same medium, that one we will consider as a reflection, correct? Now, but here when there will be a change in the medium, this one is refraction, don't get confused. This is refracted ray, refracted ray. This one is reflection, otherwise reflection ray also you can consider, otherwise reflection, that process consider as a reflection. Then here this also some part it will get reflected, even some part it will get refracted. Then here at particular angle it will neither reflect, it will not at all, it will neither refract neither reflect, it will go straight at an angle 90 degree. Then this angle we will consider as a critical angle. I will read once again here. What is the definition of a critical angle? When light goes from a denser to rarer medium, it will bend away from the normal. The angle at which the incident ray causes the refracted ray to go along the surface of the uh, two media parallelly is called as a critical angle. Here critical angle, it is indicated by theta c. See here the incident ray, when it is reached the surface of the medium, this is the surface of the medium, no, it will neither refract neither refracted, it will neither reflected, instead it will go along the boundary of the medium, otherwise it will go along the surface of the two medium. this is the surface of the two medium, it will go along the surface of the two medium. This angle we will consider as a critical angle. Understood? Listen, this is very very important one. Critical angle means when the incident ray, when it will hit the surface of the two medium, otherwise when it will hit the surface of the two medium, instead of it will neither reflect, it will neither refract, instead of that it will go along the surface of the medium. That angle, in which case the incident ray it will go straight, that angle we will consider as a critical angle. Remember, then when the incident angle is greater than the critical angle, it reflect inside the denser medium instead of refracting. This phenomenon is known as a total internal reflection. Here what I indicated in the blur line, only partially it will get reflected. Exactly it will not get full rays, it will not get reflected. Better you don't consider this one only, you will get confused. What I written in the blurred line, don't consider that one, because when you are sending the rays, so many rays you will send, correct? No, that's why better don't consider these two blurred line, consider the dark line only. Then here, after, if the angle is greater than the critical angle, particular angle is greater than the critical angle, okay, I will consider critical angle is 90 degree, means I will consider angle 120 degree greater than critical angle. Assume this angle is 110 degree. Then after, once if when you will send the incident ray greater than the critical angle, this incident ray it has to refract. You will, when there will be a change in the different medium, it has to refract, but instead of refraction it will get reflected in the same medium. This is the same medium, no class, it will get reflected in the same medium. That process we will call it as a total internal reflection. This one you can observe in the mirages or optical fiber. Understood everyone what is mean by total internal reflection? Once again I will explain here. Critical angle everyone understood. First case, if you send the incident ray at an angle of 180 degree, it will go straight, no problem. Then next one, if you send incident ray at some angle, there will be a change in refraction, it will get refracted. This also you don't have any problem. When you send a incident ray at an angle, that angle we will call it as a critical angle. Once it reach the critical angle, then that incident ray, it will, when it will hit the surface of the two medium, then that incident ray it will move along the surface of the two medium, okay, that one we will consider as a critical angle. Then what is mean by total internal reflection means, consider another incident ray. If angle of that incident ray is more than the critical angle, then here that ray once it hitting the surface, it will get reflected. This one it will get reflected, instead of refraction it will get reflected. Even though you can observe, we know when there will be a change in different medium, normally the light it will bend, it will get refracted. But here if the angle of incident is more than the critical angle, then that ray it will not get refracted, it will get reflected in the same medium. That one we will consider as a total internal reflection. Understood everyone? Where you will observe this one? You will observe this one in mirages, optical fiber. Here nicely you can observe. This one is reflection. Yes, diamond. That's why you can see the diamond, how nicely it will be shining, correct now? Understood everyone what is mean by total internal reflection? Next we will study in detail about the spherical lens. What is mean by spherical lens? A transparent medium bound by two surfaces of which one or both surfaces are curved. Normally we are having the thin from what is the difference between the concave and convex lens? Convex lens, concave lens. Convex lens means thin from the corner, it will be very thin from the corner, and concave lens thick from the corner. Then this one convex lens thick at the center, this one thin at the center. Then convex lens, this point is very important, converging lens, concave lens, diverging lens. These two, seeing the lens only you can decide, but third point you have to remember, convex lens is converging lens, concave lens is a diverging lens. Understood? In converging we will get a real image, in diverging we will get a virtual image. This also you have to remember, because yesterday we studied in detail when you will get a real and virtual image. Let us study in detail ray diagram of a concave and also convex lens. This also same as a mirror, but little changes. First rule, what I will explain always, a ray of light parallel to the principal axis of a convex lens always pass through the focus on the side of the lens. Here the rule I told, no, this rule is applicable for both mirror also, lens also. Listen here, if the ray is parallel to the principal axis, after hitting the lens it will passes through the focus. Rules I am telling, I am not considering any position. A ray of light passing through the principal focus will emerge parallel to the principal axis after refraction. Reverse of first rule. First rule is telling if a ray is parallel to the principal axis, it will emerge through the focus. Reverse, if the incident ray passes through the focus, after hitting the lens, it will emerge parallel. Correct? No? Reverse of first rule. Both also you have to remember. Then third rule, a ray of light passing through the optic center will emerge without any deviation. I am telling rules I am telling. Lens and mirrors are different, I know. I am telling the rules. Here in the mirror also we will use the same rule, no? If a ray is parallel to the principal axis, it will pass us through the focus. We will use in mirror also, no? I am telling the rules. Both are not same. I am telling about the rules. Then this is the different one. This is the different one. This one we not used in the mirror. We will use in the lens. A ray of light passing through the optic center. This is the optic center. Then after hitting the lens, again it will move back in the same direction. Understood? A ray of light passing through the optic center will emerge without any deviation. This one we not used in the mirror. Only first rule we used in the mirror. I am telling about only the rules. This also we not used in the mirror. This also we can use. Somewhere we use this one, but third one is no. This one we used. Third one no. In the mirror we used the ray, it will pass through the C, center of curvature. Then again it will reflect back in the same direction. Through C we learned in mirror. Correct, no? But here in the case of a lens, if a ray is passed through the optic center, after hitting in the same direction it will move. This direction it will move. After hitting it will move in the same direction. Only in the optic center. Let us consider the ray diagram one by one. We will study the nature of the image also. First one, ray diagram of image formed by a convex lens. When object is at infinity, we are keeping object at infinity, but here lens, here this is the lens, convex lens. here we will consider two focus we will consider, but in the mirror we are considering only one focus, correct? No, but in the mirror we will consider two focus. This is f1, this is 2f1, this is f2, this is 2f2. This is only in the case of a lens. When you keep the object at infinity, here consider these four rays, they are all incident ray. After hitting the lens, convex lens, they will meet at a single point. This one we will call it as a convergence. Okay, otherwise convergent ray. Where the image, what is the position of the image here? At f2, correct? No? Then here when it is converging, you have to consider that is real, and here you have to remember this one is inverted. And what is the size of the image? The size of the image is point size are highly diminished. Otherwise you can consider this is point size also, no? Understood everyone? Very simple. This is when you keep the object at infinity. I don't know. This is the position of the object you consider. This is at infinity. Consider four rays here. These two rays, they are parallel. All the rays, if they are parallel to the principal axis, they will pass through the focus according to the rule. Rule we know. Then that four rays, they will meet at a single point. That point, it is nothing but the position of the image. The image, it will form at f2. Convergence, convergence means real and also inverted. In the case of a convex lens, you have to consider f1, 2f1 here, f2, 2f2. Only we will consider the focus point. We will not consider the C1 to F1, both also same. You can consider F1 to F1 also, otherwise F1 C1 also. You are convenient. Use any one. Otherwise better use F1 to F1 only, F2 to F2 only. That is only correct. Easily you can remember. Next one, when an object is beyond 2F1. When the object is beyond 2F1. Okay, this is the position of an object. Then first rule, I will explain here only, easily you can follow. No, this ray is parallel to the principal axis. Always it will pass through the focus. Here, this is the focus. Always passes through the focus. First rule. Then second, already I told, if the ray is passes through the optic center, after hitting, it will come back in the same path. Both the refracted ray, where they are meeting at A dash, B dash. This is the position of the image. Then here, this also, the image is formed between F2 and 2F2, correct? No? F2 and 2F2. Here, the rays, they are meeting, therefore this is real. When it is real, always remember you will get a inverted image, ulta image here, A dash, B dash, inverted image. Then here, the size of the image is diminished, correct? No, this is the size of the object. This is the size of the image is diminished. No need to remember the ray by heart the ray diagram. Practice one or two times. Easily you can follow. Understood everyone? Are you following? Tell me. Anyone? Yes? I am not writing one more ray diagram because this is only clear. Are you following? Tell me. Anyone? Yes means I will move to the next one. Okay. Next one, when the object is at 2F1, when the object is exactly at 2F1 or C1, both also same. Okay, then here consider two rays. First ray is parallel to the principal axis, it will pass through the focus, no problem. Second ray, consider the ray passes through the optic center. After hitting, again it will move in the same direction. Okay, both they will meet at 2F2. What is the position of the image here? At 2F2. Here also it is real because the rays are actually meeting, converging. Therefore, real and inverted If you see the diagram only, you can judge. Then size of the object, it will be same as the size of the image. Same size. Those who are there in yesterday's 2-3 reflection classes, definitely easily you can follow. Those are seeing this one first time means they will take little time. Okay, next one, when the object is between f1 and 2f1, f1 and 2f1. Okay, consider this is the object. First rule, if the ray is parallel to the principal axis, it will pass through the focus. Through the optic center, it will reflect back. Both they will meet. This is the position of the image. If you draw the figure with scale and pencil nice, exactly you will get the same picture. Next, what is the position of the image here? Beyond, correct no? This is beyond 2f2. This is here 2f2, beyond 2f2. Nature of the image, actually they are meeting, converging, therefore real and inverted. Then the size of the image is enlarged. You can observe very big. Understood? Next one. When the object is at f1, exactly at f1, consider here also two rays parallel. It will passes through f2. Ray passes through optic center. Both they will not at all meeting, but they will meet at the infinity. We will consider at infinity the position of the image we will get. Okay, then here you have to assume at infinity they will meet, therefore real and inverted. Then that image is highly enlarged because you are getting the image at infinity, no? Therefore the size of the image is highly enlarged. Remember the different position. Okay, next one, when the object is between f1 and optic center. This is the f1 and optic center. This is the special case you have to remember, because at the same side of the object you are getting a image. All the cases you are getting here no image, the position of the image, but here at the same side of the object you are getting the image. Therefore consider the situation here between f1 and o. Image position on the same side of the lens. Maybe in the exam, in the case of a convex lens, where in which case you are getting the position of the image as the same size of the object, then your answer it will be between f1 and optic center. Therefore always remember the exception case, they will point out that one only. Then here see the ray parallel, it will passes through the focus. Extend the line here, the ray passes through the optic center, extend the line. Actually here they are not meeting, diverging, then virtual. Always virtual means pair is erect always. Erect means right and left, ulta. Okay. Then here the size of the image is enlarged. Understood everyone? Easy now? Still half an hour is there. I will open one more refraction. I have one more PDF. If possible, how much possible, I will explain. Understood? If you have doubt, you can ask me. Up to here, if you have the doubt, you can ask me. I think everyone you are getting the notes, correct now, nowadays? Even ma'am told, Chai ma'am, we are sending everyday notes. Huh? Are you getting the notes every day? This is also important. If possible, I will complete this one. Then if we have the time, I will discuss the MCQ question. We will study in the case of a concave lens. Are you getting the notes, everyone? Anyone reply? Yes. I'm sending today also. Yesterday or today morning? Yesterday morning, 9 or 9:30. She called me. Every day we are sending the notes, ma'am. She informed. It will be good for you, no? Let us discuss next. In the case of a concave lens, rules it will be same. I am talking about the rules. Area of light parallel to the principal axis appear to diverge here. Same rules I am explaining. If consider this is the incident ray, after hitting the surface it will get refracted, but after extending it will appear to meet at the focus. Here we are getting the virtual image in this case, in the case of a concave lens. Rule is same, but after extending it will meet. Next one, again if the ray is passes through F2, then it will get emerge parallel. Okay, this also same, after extending we will get in the case of a concave lens. Okay, next one, through the optic center, again it will passes through same, emerge without any deviation through optic center. Rules are same. Okay, let us discuss. Image position at when the object is placed and infinity. Here somewhere we will place the object. Then here consider two rays, parallel rays. Then they will appear to meet at the focus. Here they are diverging. Correct? No? Once you see the word diverging means the image is virtual. If the image is virtual means erect. Always you will get the pair like this. If the real image means always you will get inverted. Then virtual means always you will get erect. This is the pair. Remember, okay? Combination. Okay, and this one, which case you will get converging, you will get this one diverging. Therefore, here both the rays, they after extending they will appear to meet, diverging, virtual, erect. What is the position of the image at F1? Correct? No, F1 this one. Then what is the size of the image? Point size highly diminished. This is the size of the image. Point size highly diminished. Yes, easy now. Now everyone, are you feeling now? The ray diagram is easy or difficult? Tell me. You can draw mirror also, lens also. If they give the different, if they ask the different condition also, easily you can draw the ray diagram. Easily you can decide the nature of the image. Tell me, yes or no? Okay, next one. When the object is placed between the infinity and optical center. This is the optical center. Infinity and optical center. Consider this is the position of the object. This is the position of the object. Then here also consider two rays, parallel ray emerge. After extending, it will come to meet at the focus. Next one, optical center, reflect back. Extend, it will meet here. This is the position of the image. Then here you can, where is the position of the image? Between F1 and O. Then the image is virtual, erect, and size of the image is diminished. Means what you have to do in the exam also, don't get confused. In the exam, maybe one or two questions they will ask in this one, no. Immediately draw the ray diagram, fastly, roughly. Draw the, you have the scale, pencil, everything you will carry with you, no. To draw the ray diagram, it will take only how much? 30 seconds it will take. If you draw the ray diagram, then easily you can No need to remember what is the position of the object they will give. Okay. Then ray diagram, you can decide the position of the image, nature of the image, everything you can right now if you know the ray diagram. Practice, you will come to know. Then sign convention for spherical mirrors. Focal length of a convex lens always we will consider as a positive. Remember important point. This one it will help when we will solve the problems. Focal length of a concave lens is negative. Concave lens is negative. Focal length of a convex lens is positive. Then this is the lens formula. 1 by V minus 1 by U, it will be 1 by F, lens formula. Then magnification M, height of the image divided by height of the object, it will be V by U. You will come to know once we will solve the problem. Okay. Then what point you have to remember? Sorry, power of a lens. What is mean by a power of a lens? It is defined as the reciprocal of focal length in a mirror. Sorry, reciprocal of focal length in meter. What is the definition? What is mean by power of a lens? It is nothing but reciprocal of focal length in meters. Power you can consider 1 by F, reciprocal. Okay, it will be in SI units meter. Then the degree of convergence and divergence of light rays is expressed in terms of a power. What is mean by power? How much it will get converge? What is the percentage? How much it will get diverge? To measure we will use the power. Then what is the power formula? P, it will be equal to 1 by V minus 1 by U divided by 1 by F. This is the formula. Then what is the SI unit? Remember the SI unit also. Then 1 dia, dia, diapher, T is silent here. Okay. 1 SI unit of power is diapher. 1 diapher is nothing but 1 meter per second. Means 1 diapher it will be 1 divided by meter. Okay. Then 1 diapher is a power of lens whose focal length is 1 meter. What it will indicate? When you will get 1D, when focal length is 1 meter. Power of a convex lens is positive. Power of a concave lens is negative. Understood everyone? Remember, read this one. Problems also I will solve in the next class based on the magnification. Then power of a lens. We will solve problems. Okay, I told Chaya ma'am up to 5:15 I will take the class. Then fastly we will 1 minute. Fastly we will discuss the MCQ problems. Somewhere I prepared. Okay. In my laptop I don't have even space to store all these things. So many, even one topic, how many PDF notes, then MCQ questions. What I discussed same only. I prepared, I not convert in the form of a PDF. Okay, we will discuss in PowerPoint format only. It will be easy, but you will see the answer. What I have to do, don't see the answer. Okay, how can I cover the answer? If you see the answer, easily you will 1 minute, okay. If you have any doubt, ask me. Ask me if you have the doubt. Okay, we will discuss in PDF format. PDF format means you will not see the answer. Otherwise, if you know the answer before answering only, means do it. Answer the 15 minutes, only 15 minutes. I will discuss few MCQ questions, okay? Easy question only. Answer? No, I've changed. Don't see the answer. If it is visible also, don't see. A light ray enters from medium A to medium B, medium A to medium B. The refractive index of medium B is related to A. It will be greater than unity, less than unity, equal to unity. Correct answer for this question is greater than unity. Greater than unity, because once you will consider the ratio of refractive index, always you will get the greater than unity only. A light ray entered from medium A to medium B as shown in the figure. The refractive index of B with respect to A, it will be greater than unity, because here you can see this one, this is the normal. This refracted ray, it is bending, it will appear to bending away from the normal. Away from the normal means it will be more denser. Yes, Veena, you are telling correct. B is denser medium. Next, now only I explained this one. Do it. Beam of light are incident through the holes A, B, emerge out C, D. Which of the following could be inside the box? What is there inside the box? Yes, yes, sir. GK class notification came, but I informed Chaya ma'am up to 5:15 I will take the class. She will take 5:30. Don't worry. I called, I clarified with ma'am also. Don't worry. You will not, they will not start. Normally she will take the class at 5:30, no? She, early she will give the link. Once the class start, tell me immediately, I will stop. Okay? This, tell me. This one, looking only you can tell this is a rectangular glass slab. Now only I explain. Tell me this one. Which case you will get like this pattern? Here, this one is nothing but a converging. In which case you will get the convergent rays? Here, what you will keep inside this box, you will get a converging rays. A beam of light is incident through the holes inside A and emerges out of the hole on the other face of the box. As shown in the figure, which of the following could be the inside the box? What is there inside the box? Rectangular glass slab, prism, convex lens or concave lens. In which case you will get a converging rays? Someone is telling option B, prism. Prism I am not at all explained. He told anything I explained about prism. All the rays they will get converge, in which case you will get a convex lens. Only in the case of convex lens you will get a converging rays. Here all the rays they will meet at a single point, then after they will get emerge. Okay, that is option D. Don't get confused, Pratibha. Option D is the correct answer. I am not explained about the prism, no. Veena, Isha, where I explained prism. Yes, but here they are given the option only the convex lens. If you have the option concave mirror, then you can tick that also. Okay. Do next one. Do it fast. Okay, little. In torch, searchlights and headlights of vehicles, bulb is placed between the pole and focus of the reflector, very near to the focus of the reflector, between the focus and center of curvature of the reflector, at the center of curvature of the reflector. That's why you have to remember in which case you will get a in headlight of bulb. This I explained, no. Headlight of vehicles, which type of mirror or which type of lens we will use, at least guess. Remember this one, very near to the focus of the reflector, at the focus, very near to the focus of the reflector. Option B is the correct answer. No, compare this one with your ray diagram, in which case highly magnified image you will get, otherwise in which case the light it will scatter most. Focus, at the focus. Remember one or two times read, it will you can easily remember. The law of reflection holds good for which case? Law of reflection it will be holds good. Plane mirror, concave mirror, convex mirror only. All mirrors irrespective of their shape. Which case you will observe law of reflection. All the angle of incident it will be equal to angle of reflection. Then incident ray, reflected ray, normal, all they will be in the same plane. Which one? Think. Easy question, no? This one. All mirrors irrespective of their shapes. Almost all the types of mirror, plane mirror, concave mirror, convex mirror, all the mirrors they will follow a law of reflection. All the types of mirrors, concave, convex, plane mirror. Next question. This one you have to tell me the correct. Today only I explained. Which one is correct? Rectangular glass slab. Which figure is correct? A, B, C, D. Which one is correct? Tell me faster. What is your correct answer? Answer B. This one. Correct, no? This one, it will follow a rectangular glass slab. Next. You are given water, mustard oil, glycerin, kerosene. In which of these media a ray of light incident obliquely at same angle would bend the most? In which case the ray of light it will bend most? In kerosene, water, mustard oil or glycerin? Hmm? Remember the answer. Option D. Radhika. Correct. Glycerin. Yes. Glycerin, it will bend most. Next one. Okay, two more questions I will discuss. We will finish. Don't worry. Within 5:15 I will finish. At least 15 minutes take rest. Then ma'am will take at 5:30. A child is standing in front of magic mirror. She finds the image of her head bigger. See the condition. Bigger middle portion of the body at the same size than that of the legs smaller. Which order it will be? You will get which order you have to place the mirror. Otherwise lens, plane, convex, concave. Magical mirrors, plane, concave or convex or concave. See the order. In which case you will get the same size. In the plane mirror you will get the same size. In which case you will get the head bigger. Hmm? Yes. In which case concave. First case it will you will get a magnified image in concave. Correct? No. That's why your head it will look bigger. Concave. Then another one in convex, we will get convex mirror, we will get smaller image. Therefore, correct answer for this question is option C, concave, plane, convex. Plane mirror exactly same we will get, correct no? Hmm? Okay, we will move to the next one. In which of the following the image of an object is placed at infinity will be highly diminished and point image? In which case you will get a highly diminished and point image? This one you have to practice, okay? Concave mirror, convex mirror, concave lens and also convex lens. Here all the three, 1, 2, 3, 4 cases you will get. When the object is at infinity, then you will get highly diminished and point size. All these condition it will be satisfied in concave mirror also. Check with ray diagram, okay? Convex mirror also, concave lens also, convex lens also. All the fours they will satisfy this condition. Compare this statement with your ray diagram if you have the confusion. Okay. Next. Light travel faster in water, air, glass, diamond. Easy question. In which light travel faster in water, air, glass, diamond? Air. 3 into 10 to the power of 8, that is in vacuum. But air, yes. B is the correct answer. Yes. Next question. A very easy question. The mirror having reflection surface curved outward. Which case? Which case? Convex mirror. Now, the mirror having reflection surface curved inward. Easy questions. Which case it will be? Concave mirror. Convex mirror curved outward. In the case of a concave mirror, the reflecting surface it will be curved inward. Like this now. This is the reflective surface in concave in sorry In convex, it will be like this. Correct, no? Yes, remember the lens, mirror, what is the shape? Hmm? Next question. Deviation of light when it travel from one transparent medium to another. Very easy question. Tell me. Tell me. The deviation of light rays when it passes from one transparent medium to another transparent medium. Refraction, no. Convex lens is also a converging lens, diverging lens, a radial lens, axial lens. Converging or diverging? Convex lens is a converging lens. Thorough the concepts, still you have the confusion. The image which is formed behind the mirror, in which case the image it will form behind the mirror, real image, virtual image, blue image or partial image. Behind the mirror, after extending we will get the image, no? After extending we will get the image, that is virtual image only. Then this is the last question. Almost I finished all the questions. Hmm? Revise. I know still you have the confusion. So many you are only few you given the correct answer, but remaining still you have the confusion, means you have to read the theory properly, revise the theory one or two times. After revising, start answering the questions, then you will come to know. Understood? Okay. Thank you everyone for joining my class. Now already 5:15. Okay. Take 10 minutes rest. Then Chaya ma'am, maybe she will be waiting for me when ma'am will close, when I will start the class. Huh? Better we will meet tomorrow, our as usual classes. Why I am taking extra classes, you know, no? Because next week, maybe full week, I will be not available. Hmm? Because I am going to my native after 4 or 5 months. I am going to native. I don't know. Depend upon the my, if anything, if I want to extend. That's why I'm taking more class. If I come early, don't worry. I will engage the class. If I go more days, means I am not able to. That's why. Okay. Bye. Take care, everyone. Read.